Okay, for Team Nimbo, please tell me whenever you're ready.
Okay, we are ready now.
Okay, the timer will start counting when you start speaking. Team Nimbo, the time is yours. Good luck.
Thank you for this opportunity. The Honorable, all of the judges in this competition. Let us introduce ourselves. We are from Nimbo team. I'm Afrizani Matusada and my partners Mauren Yudit and also Imam Fauzi. Today, we will present about the technology innovation for sustainable future of industry. Our presentation today consists of the background, the solution and innovation, the project feasibility, and also the conclusion. So let's start with the background section. Coffee is a superior commodity for Indonesia as the fourth most coffee producing country after Brazil, Vietnam, and Colombia. As we can see on the screen, that the coffee production increased until it reached 780,000 tons in 2020. For the next slide, we can see together that based on the data from statista.com, coffee consumption in Indonesia has increased significantly. Together, we can see that based on the data from Indonesia Coffee Annual Report, Indonesia ready-to-drink or RTD coffee product has increased significantly. The impact of these three coffee phenomena is the emergence of coffee shops. Based on the data research, Indonesia had more than 2,950 coffee outlets in August 2019. Compared to the number of coffee outlets in 2016, there has been a very large increase in the number of coffee outlets. It needs something unique from a coffee shop to be able to compete and get lots of customers. One of these unique things has been demonstrated by a local coffee shop located in Surabaya, Indonesia, Katura Espresso. Katura Espresso not only sells the coffee, but also sells food menu items. Therefore, this is the percentage of Katura Espresso West. The percentage of Katura Espresso West consists of 6% oil fat, 10% vegetable, 2% coffee grounds, 40% food containers, 20% straw, 7.5% leftovers, 10% pepper, 0.5% glass, and 4% wastewater. Katura Espresso produces 10 until 50 kilograms of paper and glass waste every day. And we can see together that the Katura Espresso also produces 1 kilogram of coffee ground waste every day. Suppose we have assumption that all coffee shops in Indonesia produce the same waste as Katura Espresso. In that case, plastic waste from coffee shop contributes 72% of national plastic waste in Indonesia. Can you imagine that? The simple impact caused by coffee waste is the unpleasant odor that quickly appears, especially when it rains. So, it will cause the environmental pollution if it is not handled correctly. Therefore, we need a solution. I can say that there are many solutions to overcome the environmental pollution, but they are still far from solving the environmental pollution. There are three alternative solutions to solving the environmental pollution from coffee waste. The first alternative solution is the regulation for waste processing methods for coffee shop in Indonesia. But I can say that it takes a long time to make and pass a regulation. Another alternative solution is utilization of coffee ground waste for the wallet production, for the bioethanol production, animal feed, carbon active, and etc. But I can say again that these alternative solutions do not have a significant effect because they only use low quantities of coffee ground waste. And once again, I can say that this alternative solution not the most viable. So, as a chemical engineering student, we propose the technology innovation for sustainable future of industry. Our innovation is utilization of coffee shop waste as the composite to produce monoport at Katura Espresso. particle board as the composite material made from two constituents. First, filler, which function as the main load barrier of the composite. And second is the matrix solution. Based on the previous research, we can get an information that the best particle board produced from 30% filler and 70% matrix. So in this innovation, we're using this composition. In this innovation, paper waste and vegetable waste are used as a filler using extraction and purification process, while polypropylene plastic waste used as a matrix using heating process. Vegetable waste is used as a filler because it has crude fiber content up to 22%, while paper waste contain high cellulose up to 70%. This high cellulose fiber content from the paper or vegetable waste will produce higher performance from the particle board. The use of polypropylene plastic waste as a matrix because it has superior properties such as liquid but strong, transparent, and waterproof. And these superior properties will improve the physical and mechanical properties of particle board. This innovation has some benefits, such as reduce the use of paper and bring a lot of profits. But I can say again that this innovation has some weaknesses. The particle board produced from this waste are easily degrade when exposed to sunlight, have low flexural strength, low dimensional stability, and low resistance to chemical and moisture. So, how to overcome this weakness? We propose the addition of oil adhesive to particle board. The oil adhesive compound can improve mechanical properties, prevent watering, and prevent autocatalytic photodegradation under UV exposure. The particle production process includes some steps. First, the filler formulation. Second, the matrix formulation. Third, the oil adhesive formulation. And the last is mixing and printing process. The matrix, filler, and oil adhesive material are mixed together and stirred until they are homogeneous. Then it was printed using a hydraulic pressure for 30 minutes. The resulting particle board will be coated with oil adhesive and dried. The function of the coat is to prevent the autocatalytic degradation under UV exposure. As you can see on the screen, that this is the production area layout and design from this technology. For the next screen, we can see together that this technology only uses oil and fat waste, vegetable waste, food container waste, and paper waste. The total waste requires up to 95 kilograms. And after the waste treatment is carried out, a composite solution produced from the treatment up to 46 kilograms. Next, let's discuss about the project feasibility from this innovation. From the economic analysis, we can compare the benefit and the additional costs received by this technology. The benefit received from this technology can be classified into three types. First, environmental value. Second, economical value. And the third is indirect benefit. From the environmental value, we can see together that this technology can treat waste up to 95 kilograms per day. It means that this technology can reduce the category special waste up to 66%. While an economical value includes the increasing revenue and reduced incurred costs. From the indirect benefit, we can see together that this technology can preserve the environmental and improve the labor knowledge. To find out the additional costs from this technology, we need 4 types of data. First, chemical use. Second, type and cost of the equipment use. Third, energy consumption. And the fourth is total wages for the labor in waste treatment sector. As you can see on the screen, that this is the additional cost for the chemical use. The additional cost for the chemical use up to 772,000 Indonesian rupiah. For the next screen, we can see together that this is the additional cost for the equipment use. And the additional cost for the equipment use up to 36 million Indonesian rupiah. For the next screen, we can see together that this is the expenditure for the electricity per month. We only spend about the 100,000 Indonesian rupiah to operate the crusher, to operate the oven, centrifuge, cooler, and mixer. And this is the additional cost for the labor wages. We must spend about the 6,300,000 Indonesian rupiah. From the economic analysis, we have a conclusion that the benefits obtained from this application are greater than the additional cost that must be incurred. For the next screen, we can see together that this is the calculation of the profit earned from this technology. By producing 66 particle board per day, we get revenue of 39 million Indonesia rupiah with a total profit of 10 million Indonesia rupiah. On this social impact, this innovation can increase the labor absorption, can increase the labor employment, and also increase workforce insight. Next, let's discuss together about the SWOT analysis from this innovation. I can say that lack of education about the production of composite material from the waste treatment can be a weakness. But this innovation has so many strengths, such as Katura Espresso produces various types of waste, including the paper, vegetable, polypropylene, and oil waste, which complement each other to be used as a raw material for particle board. And this raw material has superior properties, such as the paper waste contains up to 70% of the cellulose that will be the superior properties for the particle board. And the resulting particle board can be sold to generate a profit of 10 million Indonesian rupiah. But we must remember together that the risk of chemical use can be a threat. And also frequent equipment maintenance is also needed in this technology. On the other side, this innovation provides many opportunities, such as reducing Katura Espresso waste, reducing polypropylene plastic waste on the national scale, and also absorption of the labor. For the conclusion, I can say that Katura Espresso waste is potential to become particle board composite material. This technology uses paper, vegetable as a filler, and polypropylene plastic as a matrix, and all adhesive as adhesive compounds. But series of process is necessary to obtain to produce a good quality of particle board composite. Based on the economic analysis, environmental analysis, social analysis, and future opportunities, I can say that the application of Katura Espresso waste treatment technology is a business strategy that is feasible to run and has great potential to continue to be developed. This is our presentation, and thank you very much for your attention.
Okay, thank you very much for Team Nimbo. Okay. Oh, your presentation is so cool and have so many materials. And can I ask about your feelings after your presentation today?
It's better than before presentation.
Do you still nervous?
No.
No, okay. And before we move to the question and answer session, I would like to introduce the judges first. We have Mr. Kenny, Miss Siti, and Miss Diane. Are you ready, Team Nimbo, for the question and answer session?
Yes, we are ready.
Yes, we are.
Okay. And also, I would like to remind again about the timer. You may pin the timer to tell the time limit about the Q&A session. Okay. And in this Q&A session, all the team members can speak and on their microphone if you have an answer for the questions. Okay, for the first question, can we have Miss Siti?
Okay, thank you. Congratulations for Nimbo teams. This is the great idea to
utilize the waste from the coffee shop? I have several questions. First, how to determine that the plastic type is polypropylene, not
Okay.
PET? Usually for food, we use PET, not PP. And the next
Okay.
question, what is the composition of filler, matrix, and adhesive? You use polyurethane. And
Yes.
I imagine actually when you mix, it will be still, because you say 30% filler and 70% matrix, and the matrix in the liquid phase, is it right? So if 70% of the matrix in the liquid phase, so when you press it, it is liquid. So how can it become a particle board? And the last
Okay.
question about the cost. You analyze the economic, but you mentioned that the cost of capital cost for the equipment, you state that the price per product, but I think it should be the price for one equipment. So you should buy the equipment. So you need to calculate the capital cost or the capital investment.
Yeah. Okay.
Okay, that's my question.
Okay, thank you, Miss Siti, for the questions. And Team Nimbo, are you ready to answer the questions?
Yeah, we're ready. Okay, thank you, Mrs. for this question. So actually, we already contact the Qatar Espresso. I mean, the staff of Qatar Espresso via Instagram, and we get an information that Qatar Espresso using food container under the brand of Swapi. And we search in the Google that the Swapi is polypropylene plastic type. So we decide to using polypropylene plastic type, because I think that the percentage of the food container from the Captura Espresso waste is higher than the other waste. It Yeah, that's it. And for the second question, um, actually, we decide about the composition of this particle board. I mean, 30% of the filler and 70% of the matrix because of the previous study. The previous study state that the best particle board is produced from the 30% filler and the 70% matrix. So we just adapt for the prestige paper. And for the capital investment, we already calculate about the cost of the equipment, about the chemical use cost, and we already calculate them. Maren, can you present it? For the equipment calculation. Yeah, this is the calculation of the equipment used in this technology. So we can see together that this technology is spent about the 36 million Indonesian rupiah in this technology. So if we want to generate this technology, we must to spend this about the 36 million Indonesian rupiah to buy the equipment. Thank you. Maybe another member can add my answer.
Okay, maybe
Yeah.
the other team member? Okay.
Yeah, I think may I adding some statement that we use this technology, that we also do research about the materials we use, because it's really a fundamental things. We have to we have to really discuss and to choose whether to use polypropylene or polyethylene, and we have to determine it really strictly. Yes.
Okay.
As addition, maybe based on the previous research, maybe the particle board, the best particle board produced from the polyethylene plastic type. But back again, that the Qatar Espresso is using Suwapi brand as the food container, that the type is polypropylene plastic type. So we are using the polypropylene plastic.
Okay.
May I add some comments? I think in the cost of equipment, in here you just say, for example, crusher, 2,800,000 rupiah per pieces. So actually you should write crusher, one crusher, how much it is. Because like you saw in the flow diagram, it is like you make a small company, small factory. So you need to determine how is your crusher, how big, what is the material, and also the tank, what is the volume, and often centrifuge, what kind of centrifuge, and separator, what kind, and how is the size, what is the material. So in here, you should write one crusher, how much it is. So in here is total capital investment, not price for one product. So I think this is my suggestion. Okay, thank you.
Okay, thank you, Miss. Thank you, Miss Siti, for the suggestion for Team Nimbo. And for Team Nimbo, is there anything you would like to say about that?
I think it's enough.
Okay. And for the next question, can we have Miss Dianika? Hello, Miss Dianika.
Hello, sorry, my connection is a bit unstable. Can you hear me well from the other side?
Yes, it's clear.
Okay,
Yeah.
very good. Thank good, because previously it's a bit unstable. Okay, so congratulations for the presentation. A very nice ideas, that you presenting, and also in a very excited manners of presentation. My question, is you address the waste from the Katura espresso, and you propose to make a composite for the menu board. I wonder, because in a cafe, the menu board, maybe needs to be provided in just a certain number. So if the cafe have enough menu board already, so while the waste is continuously produced, basically. So what are the strategies? Do you have another target consumer for your composite board? Or maybe you can explain more about that. Thank you.
Okay, thank you, Miss Dian. Okay, for Team Nimbo, the time is yours.
Okay. So I answer first. So from the previous research, we already know that the particle board not only used as a menu board, but also for the thermal insulator, for the wall partition, for the door, and for the other furniture household. So actually, we can get a lot of partners to produce a lot of application of the particle board, such as the thermal insulator or door or wall partition or furniture household and etc. So I mean, like the market is very large for the particle board.
Okay, thank you, Team Nimbo. And for Miss Dian, are you satisfied with the answers?
Yes, okay. Thank you very much for your answer.
Thank you, Miss Diana.
Okay, and for the last question, Mr. Kenny.
Hi, I think it's a very good presentation from Nimbo.
Thank you.
And I think it's a very creative idea. And I think the main hurdle to this idea would be the logistics, and because the scale of just one coffee shop and the waste is not too significant. But if you all can set up maybe a company to have a buy-in scheme for coffee shops, so the company can buy like the coffee waste from cafe A, B, C, D, E, restaurant A, B, C, and then consolidate that, then the cost and the business expense and the profit would be more justifiable. And it depends how expensive the cafes and coffee shops would be willing to sell the waste for. But I think it could be a big thing if done properly. And since the cafes just usually throw out the coffee waste anyway, so they have nothing to lose.
Yeah. Okay.
Maybe you have ideas on how to make the scalability hurdle more possible to achieve. That's I think that's for me. Thank you.
Okay, thank you, Mr. Kenny. Okay, and Team Nimbo.
Is the discussion session has ended or not? It's still going, right?
Yeah, you can still answer the questions.
Okay, thank you very much for the question, Mr. Ken. So I can say that this innovation is viable to scale up because we already have the PFD or process flow diagram, and we have the design and the layout of the plant. And actually, if we want to combine so many coffee shops, like actually from coffee A, B, C, D, maybe we can to buy the waste from the coffee shop and we can to put into the into certain room, like in waste shipping room, and we can to build such a certain location for this innovation. So maybe it's easy for us to scale up this idea because I have already have the process flow diagram, I have already the area layout design, and I already have the equipment that will be used in this innovation, and I already have the kinetic ration of each ration in this innovation. So I think it's easy to scale up. Yeah. Maybe another member want to add my answer?
Yes, in addition, I would like to say another sentence that I think that the diagram scale and the overall process flow diagram, it has been created importantly because we also consider the cost, and even the assumption for the waste is we generating all the cafe shops in Indonesia, so the amount of waste produced from many other coffee shops, not only in Surabaya, but it also generating from all cafe, and that we doing some formulations to calculate the total materials we can achieve from that. So I think it's gonna be more feasible for us to having this.
And as addition, our target is not only the coffee shop, but also the restaurant too, because the restaurant also produce the vegetable, the pepper, the oil. So we can to combine with the restaurant waste together.
Okay, thank you, Team Nimbo. And Mr. Kenny, are you satisfied with the answers?
Yeah, I think it's a great idea, and maybe if you all try to pursue this idea in the future, then it can be something that benefits both the F&B business and you all for setting up the company, and it's a win for each party, for all. Thank you.
Thank you, Mr. Ken.
Welcome.
Okay, thank you for all the judges. Thank you for Mr. Kenny, Miss Diane, and Miss Siti for the questions. And thank you for Team Nimbo for the presentation and the answers. And for Team Nimbo, I would like to remind you to attend to AIChE 2021 Social Night, which will be held tonight at 7:20 p.m. and the conference and awarding day tomorrow, which will be held at 8:30 a.m. Okay, thank you for Team Nimbo. Good luck.
Yeah, thank you so much.
So much.
Yes, you're welcome. Thank you, and